Okay, so hello everyone. The question which we will be solving today is longest nice subarray. Okay, so as you can see, the question number is 2401 and it is marked as a medium one, right? Okay, so now let's just read the description and try to solve this question, right? So you are given an array nums consisting of positive integers. Okay, we call a subarray of nums nice if the bitwise AND of every pair of elements that are in different position in the subarray is equal to 0. Okay. Return the length of the longest nice subarray. Subarray is a contiguous part of an array. Okay, we know that. Okay. Note that the subarray is of length. Okay. So what we need to do is that we need to find a longest nice subarray. Okay. So what is nice subarray? Nice subarray is a subarray in which, like suppose in which, in this case, 3, 8, 4 and 3, comma 8, comma 40. This is a nice subarray. Why? Because like if you do AND of 3 and 8, you will get 0, right? And if you do 3 and 48, you will get 0. Similarly, 8 and 48 will also give you 0. Okay, a subarray is a nice subarray if all the pairs, like all the pairs, when we do AND of it, we will get 0, right? Okay, so we need to return the longest nice subarray. Okay, so let's just try to solve this question, right? Okay, let me just take this example here. So what are the elements? 1, 3, 8, 4, and 10. Okay. So we have given 1, 3, 8, 48, and 10. Okay. So this is a this is the array which has been given to us, right? So what will be our approach, right? We can find all the subarrays. That would be a approach like 1 comma like 1 comma 3, 1 comma 3 comma 8, and what we can do 1 comma 3 comma 8 comma 48 comma, okay, 48, and let me just copy this. Okay, okay, so and this can be a, okay, one way we can do it like this, right? Okay, so what's the like suppose now we consider this subarray, right? And like something like this. Okay, so by like doing like this, we can generate all the subarrays and we can just like store which is the maximum. Okay, in the similar way we will be doing like see, this will give us an answer. Okay, so this will give us our answer. Okay, we know that, but we will see how. Okay, so like what will be the time complexity? Okay, so talking about the time complexity, like for iterating it again and again, we will be like okay, so can we say something of like big of n square, right? Big of n square. Okay, so this won't be working. I mean, will be working, but see, the constraints are high. Okay, so it won't get accepted, right? Okay, so we need to find a better way, right? So let me just show you like what's happening here, right? So as you can see, we are doing the and, right? Okay, so let's just see how things are working. Okay, so should I write this in binary? So like what will be the binary, like straight to it's just a trick. Okay, you might know how to do it. So, like by this we can find out the binary representation. So for 1 we will be getting 1, right? So and for 3 we will be getting what, like 1 1, right? Okay. And for 8 what we will be getting, like what is 0, we will get something like this, right? And for 48 we will get something like 32. Okay, we will get 1 1 and 4 zeros, right? And for 10 what we will be getting, we will be getting like 1 0 1 0. Okay, 1 0 1 0, right? So can I write something like this? Okay, so can I say that it's written something like this? Okay, this is our 1, this is our 3, and what is this? This is our 8, this is our 48, and this is our 10, right? Okay, okay. So like suppose we are here, suppose we are here, right? We check, like we do the add with the previous element. Okay, so what we will get, mm, we will be getting like 1, because we won't be getting 0, right? Because this one and this one matches. So we move forward, right? Okay. We come here, right? We check from the previous one, this one will come here, and we will get what, 0. So this is like we can say we got 2 elements, right? Okay, then we move here and we check it with this one, right? And we also check it with this one, right? Okay, okay, so like one will come here and this 2 ones will be coming here, right? Okay, so now what happens, this window will be like something like this, right? So now we check this with this, right? For by checking with this, it's okay, right? Uh, it's okay, but while checking this isn't okay, right? This isn't okay. This one will come here and it will give uh, okay, like okay, no, not this one, sorry for that, not this one, this one will like match with this one. Okay, so here is also the time complexity is like not so good, because it's not a like but this is the intuition, right? Okay, so from here let's see we can get something or not. See, once we consider like start expanding our subarray, okay, we know that like see, this is our answer in the like for final case, right? Okay, this will be our answer, right? We know that, okay, because it's given. This is given, right? Achha, okay. So tell me this, that like if we write it like this and this, so can you see that at like each place there's only a single one, right? Can you like observe it? Like for this place, like suppose it's let me just do, okay, let me just do it, right? Okay, then things will be more clear. Suppose this is the zeroth position, this is the one. Oh, okay, let me just, I just have to like 0 1 2 3 4. There are there more elements? Okay, there are 5. Okay, and here the elements will be 0 because the thing is there, so we can write 0 0 and we can just like move it here. Okay, good. And how many elements are here? Like 2 are here. Okay, one is extra. So can you see that at each position, like the 0 position, there is only one? Yes. At the first position, there is only one. Yeah. For the same like 2, 3, oh no, not for 3, 2, 4, and 5. Okay. As soon as this 1010 comes, what happens? Like what happens? Let me just show you what happens. Okay. What happens here, right? 1010. Okay. As soon as this comes, this has a trouble with this one, right? And this will also have a trouble with this one, so it will give you one, right? It's bound to give you one. Okay, okay, okay. So so what we can do, we can check. What we can check, suppose for like this part, suppose we didn't come to this 10, right? Okay, so suppose this is our answer till now, right? Okay, so can we like store it in some form? Like what I mean to say, that it something like we can do something like this, right? Like kind of a mask. It's a kind of mask, right? Like mask or check, whatever you can say. Okay, okay, I'm not able to write it properly. So if this and this, right? If this gives us 0, then only we'll be considering it, right? So how can we make this mask? See, this is the question of a bitwise. So you might be knowing that if we do XOR of it, what will be our answer? This is what we will get. So while expanding the window, we will be making this mask. We'll be doing XOR. And as soon as like if this condition is false, we will be shrinking our window or the subarray. Okay, so it's kind of this question is kind of a mixture of a sliding window and a bitwise bit manipulation, right? Okay. See, you have to do dry run of this to understand it, because without doing it practically, you won't be getting it right. Suppose we were here. If we consider this like suppose we started from 1, right? So when we come here, 1 is already there. If we do and, you won't be getting 0, right? So you shrink the window. You shrink the window. Okay. So now from where you will be starting? You will be starting from here. So the mask will look something like this or not, right? So when you do this with this, okay, you won't be getting, you will be getting 0. So what do? You just mask it, right? 0, 0 comes here, 0 comes here, and 1 comes here. So if you do the XOR of it, what will be the answer? Won't it be like something like this? 1, 0, 1, 1. Am I right? Yes, I am. And suppose in see what this is having, if you check this with this, you are automatic, if this with this, you are automatically checking for these two also. So you can like do it in a linear fashion, like you don't have to go like for each iteration backwards, right? You are doing it in a single go. It's a big often, right? And after like bit masking it, you will get one, 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 0, 1 and 1. And when you will be checking it with this one, with this one, you will be getting what? You will be checking, automatically checking it with this, because the set bits of this are stored in the mask, right? You will be automatically checking it with these ones, right? Okay. So yeah, this is the concept, right? Okay. Let me just show you the code and you will get it right. Okay, so this is the code. Okay, so simply the count will already like we start from 1, right? The count initially will be 1 because let me just show you. Oh, wait, was it? Note that the subarrays of length 1 are always considered nice. Okay. Because see, there's also a reason for it, right? Suppose if you do 3 XOR 3, I mean 3 and 3. Okay, so no, 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 that's not the case. Okay. Okay, so it will be always considered one. Okay, so that's another concept. So the max count will also be 1, right? Okay. So mask, what will be the initial? It will be equal to the initial element, right? I will be starting from like the next one, and j will be at the 0th position, right? Okay. While j is less than n and mask and nums of I is not equal to 0, what do we do? Right, in this case we are unmasking it, but aren't we masking like this? Yes, but we can, if we do it twice we will be unmasking it. Okay, so let should I, do I have to show you? Right, okay. Okay, so like suppose how do we write 3 like this? Okay, so like suppose you mask it with 100, right? What you will be getting if you do the XOR of it? You will get 1, 1 and 1. And if you the XOR it with 1, 1 again, 1, 1, or let me just, so yeah. So what you will be getting? You will be getting like 1, 0, 0. So see, here we are going this way, like we are expanding the window, right? So we are here, we are doing it for the first time, and from here we are decreasing the window. Okay, so when we do the masking here, it is shrinking, right? So in order to remove it, we are doing this, right? And we are increasing the j plus plus, okay, and the count minus minus. Okay, and if that's not the case, we are simply doing this, right? And at each stage we are calculating the max count. Okay, and at last we are just returning the max count. So the time complexity here will be big of n, right? Okay, so that's a linear time complexity, and just a second. Yeah, so yeah, that's for the question, and as you can see, the code is running fine. Okay, so I think that I've taken this long for like some reason, but yeah, that's not like necessary here because I was thinking of edge case. Okay, so like if you take int, it will be like a better time capacity, I guess. Okay, so yeah, the code is running fine. Okay, so as you can see, the question link and the code link will be in the description box. And yeah, that's all for this question. Have a nice day ahead.